Hello everyone, my name is Shruti. I'm currently pursuing engineering in CMRIT College, Bangalore, and I'll be presenting my project which I made during the internship at Emertxe. Table of content, overview, introduction to C programming, introduction to embedded system, introduction to microcontroller, and we'll get to know about the PICSIM lab, overview of PIC16F877A microcontroller, which includes CLCD, matrix keypad, ISR, and timer, and the required software which we use for projects, for project microwave oven, and at last we'll have a project demo. Coming to overview, in the first week we got to know, we learned about C language, uh, where the conditional statements, which includes if, else if, and loop, where for loop, while loop, and we got to know about arrays, pointers. Next week we had introduction to embedded systems, where we got to know the different types of embedded systems and the microcontrollers which we'll be using for the coming project. And for this project we'll be using a PIC16F877A microcontroller, which includes LEDs, matrix keypad, CLCD, and timer. And for the project we use MPLABX IDE, PICSIM lab software, and a XE8 compiler. Coming to introduction to C programming. C programming language is a general purpose language created by Dennis Ritchie at the Bell Laboratories in 1972. It is a very popular language despite being old. The main reason for its popularity is because it is a fundamental language in the field of computer science. C is strongly associated with Unix, as it was developed to write the Unix operating system. C language is widely used because it is easy to learn, it is a structured language, and produces efficient programs, and also performs low-level activities. The next is introduction to embedded systems. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. And the examples for embedded systems are microwave, washing machine, etc. The categories in embedded systems are standalone, real-time, network, and mobile embedded system. The requirements for an embedded system are the reliability, the cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. Coming to the types of embedded systems, we have standalone, mobile, and network embedded systems. Standalone embedded systems are a type of embedded systems which do not require a host system such as computer or processor, as it works by itself and displays data on the connected device or make necessary changes on the device. Examples are digital camera and digital watch. Coming to mobile embedded systems, all the devices that are portable and working with an embedded system is a mobile embedded system. Though there is a limitation of memory and portability, and the examples for such systems are mobiles, laptops, and calculators. Network embedded systems. When a program is running inside another device, a network is formed, and this network is called as network embedded systems. In this system, a microprocessor or a controller controls the running program. A network is related to this system and they can either be LAN or WAN. And the examples for such systems are home and office security systems, automated teller machines. Embedded systems play a major role in our day-to-day life. Coming to advantages and disadvantages. In advantages, it is effortless to understand as it is simple and it executes a similar task continually, hence there is no requirement for changing hardware such as additional memory or storage space. The applications of embedded play a major role in industries. The time taken to develop an application program is less. The embedded systems can run predefined programming. Coming to the disadvantages, it performs only one task at a time. It only supports the hardware system and it also has issue of scalability. That is, it can't easily be scaled up as scope change or demand. It has limited memory or computer compatibility. The basic structure of embedded C programming is as follows. A multi-line comments can be denoted using a slash and asterisk sign. A single line command can be denoted using double slash. A preprocessor directives such as include and define are defined using ash, include, and angle brackets. The variables which can be accessed anywhere in the programs are called as global variables. There is function declaration, that is declaring a function, where user-defined functions also include. The syntax of programming the function is as follows. Main function that is execution begins here. By using these flower brackets, within these flower brackets we write the required program, where local variables, functions are called and there is infinite loop according to our requirement and the statements are also present. Function definitions, that is you are defining the function used here, where local variables and statements are present. Coming to data type. There are various data types in programming whose sizes and range of values are given. So, void, bool, char, unsigned char, byte, integer, unsigned int, word, long, unsigned long, float, double, string. The size of char is 1 byte, which is 8 bits, and the range of char is -128 to +127. And whereas for unsigned char, it is 0 to 255. That is, for char, there is negative values as well as positive, but whereas for unsigned, there is only positive values. So for us to consider only positive values, we use unsigned char, unsigned int, unsigned long. But whereas if we require both negative and positive, we use long, int, and char, where char size is 8 bits, int size is 16 bits, and long size is 32 bits. Depending on our requirement, we use the data types. Introduction to microcontroller. An integrated circuit which is capable of being programmed to perform a specific task is known as microcontroller. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. The different types of microcontroller are 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller, etc. Microcontroller is a compressed microcomputer manufactured to control the functions of embedded systems and offline machines, robots, home appliances, motor vehicles, and a number of other gadgets. To choose a microcontroller, there are certain conditions we follow. That is, we check the application, performance, price, and availability according to our requirement. The important terms are host. A system which is used to develop the target is known as host, and target is defined as the system which is being developed for a specific application. And cross compiler is defined as an application used to generate code for another architecture being in another architecture. PICSIM Lab. PICSIM Lab is a real-time emulator of development boards with integrated MPLABX debugger. PICSIM Lab have integration with MPLABX or Arduino IDE for programming the boards of microcontroller. PIC microcontrollers are meant to enable simple programming and interfacing in embedded system design. Most of the PIC microcontrollers that hit the market are 8-bit microcontrollers, although Microchip did introduce some 16 bits and 32-bit microcontrollers. For our project, we will be using PIC 16F877A, whose architecture is as follows. We have LEDs, buzzer, digital keypad, SSDs, matrix keypad, temperature sensor, RTC, and GPIO. Going in detail of LEDs, buzzer, digital keypad is in the next slide. LEDs. We know that LED is a light emitting diode, which is a semiconductor device that emits light when current flows through it. Buzzer. Buzzer is an electrical device which is similar to a bell that makes a buzzing noise and is used for signaling. The typical uses of buzzer, which are also known as beepers, include alarm devices, timers, and confirmation of user input such as a mouse click or a keystroke. Digital keypad. Keypads are widely used input devices being used in various electronics and embedded projects. They are used to take inputs in the form of numbers and alphabets and feed the same into system for further processing. Timers. They allow us to measure the time taken to execute, create non-blocking code, precisely control pin timing, and even run operating systems. Coming to interrupts. Interrupts are the signal which alter the flow of an executing programming by causing the microcontroller jumps to the interrupt service routine, also known as ISR, to serve the interrupt. For this project, we will be using CLCD, whose full form is Character Liquid Crystal Display. There are two types of CLCD: 16 by 2 display, 16 by 4 display. This CLCD displays the ASCII characters. It is commonly used to display two types of communication mode. They are 8-bit mode, 16-bit mode. This is how a CLCD looks. And these are the pin details. Coming to keypad interfacing, which is also being used in the project, we use a 4x4 matrix keypad for this project. So there are 4 column lines, 4 row lines, and in between the row and column a key is implemented. And as shown in this row, column, and these are the keys which are present. When the key is pressed, the columns and row are connected. The required execution is done. That is, when the key 1 is pressed, row 0 and column 0 are connected, and according to the requirement, the following operation is done. And when key 1 is not pressed, there is no connection between row 0 and column 0. Here, the columns, that is C1, C2, C3, C4, are the inputs to the microcontroller. Microcontroller code reads C1, C2, C3 and C4. They read the columns to detect the key pressed, and the rows R1, R2, R3, R4 are the outputs to microcontroller. Coming to ISR. ISR full form is Interrupt Service Routine. An ISR is a software routine the hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing interrupt flag and save the register contents that might be affected by the code in ISR. It must be terminated with the instruction RT. When an interrupt occurs, the MPU completes the instruction being executed, and then it disables Global Interrupt Enable. Place the address from the program counter on the disables Global Interrupt Enable. Place the address from the program counter on the stack. Coming to timer. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. It has many applications such as measuring time and generating delays. A timer or counter is a software designed to count the time intervals between the events. Resolution, which is also called register width, that is, it is 8 or 16-bit. TIC is referred as the change from one number to the other number. Timer may be up count or down count, which depends on the system clock setting, and it is a measure of time which is responsible for the scaling, either pre-scaling or post-scaling. For our project micro oven, the software we used are PICSIM Lab, MPLAB IDE, and XC8 compiler, and the hardware include microcontroller PIC16F877A, an LCD display 16x4, keys, buzzer, fan, timer. And for the code, we have used this syntax for main C file, and for main.h we have used this syntax. Micro oven. A micro oven is an electric oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. And the principle behind this oven is the oven heats food by passing microwave radiation through it. Microwaves are a form of non-ionizing electromagnetic radiation with a frequency in the so-called microwave region 300 MHz to 300 GHz. So for our project, we implement 4 modes such as micro mode, grill mode, convection mode, and start mode. That is, we set these modes and then start the heating process. And in our day-to-day lives, microwave has many modes, but for our project, we have selected micro mode, grill mode, and convection mode. Micro mode. This mode is used to cook in a traditional way. It uses a maximum power of 900 watt in this maximum time that the user set for cooking, that is 60 minutes. Grill mode. This mode is used to cook meat and bread. It works as the same as micro mode, but the only difference is that it is used to cook meat and bread. The user can set time as per the required cooking time. Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, the user can set the time as per the requirements. Coming to project demo. So using MPLAB, we have programmed, and the program files are present here. Main.c, which is the main program where LC, CLCD, matrix keypad, timer, and ISR are present, and there are header files also included. So after building our program, we save and then we build. As you can see, build is successful, and now using this program we load it in PICSIM lab, and I have taken a video where I've already loaded it. So now after loading it in the PICSIM lab, we get these options. First one, micro, grill, convection, and start. So now by clicking one, we see the power is 90 watts. Now to set the time, where the first half is minutes and the second half is seconds, we choose the key 2 and we set it to 2 seconds. And in order to clear this, we press this asterisk. We can see that this is the fan which is rotating, and now as you can see the timer is and the cooking time is up, and we hear the buzzer sound. And then we come back to the original thing where we can see all the convection modes. Now by clicking key 2, we go into grill mode, and the time is set using this key. Based on our requirements, we can press the time. So for this one, we have clicked 5 seconds and then the microwave is on. Now to start or resume, we can press key 4. That is, we can see the time has increased by 30 seconds. Now again, by pressing key 4, it gets increased to other 30 seconds. Now to pause it, we press key 5. We can see that the fan is stopped. That is, the microwave has been paused. Now to come out of the mode, we press key 6. This is the demo. And the references used for doing this project is by Emertxe Information Technology. Thank you.